Hey, today we're gonna do our last IMB of chapter 3, which is on how to graph a polynomial function. So this is putting everything together, and we're gonna start with symmetry. So we want to prove whether our polynomial function is has symmetry either across the y-axis, symmetry, and that would be if we have an even function, or origin, it's right across the origin. Symmetry, extra m, and that would be if I have an odd function. So notice this IMB is just going to be telling us what to do, and then our next video will be me following a problem specifically through and how to do that. So we already learned symmetry, and we know if we plug in a negative x into the function, and if we output the same exact function, then it's going to be even. So that would be our first thing that we're going to do. And if I put in a negative x and I get back the exact opposite function, then we know that that is a odd function. And the third thing is if I plug in a negative x and my output is neither f of x or the exact opposite, then it's no symmetry. Okay, but you have to show this work of plugging in the negative x. Okay, the next thing we're going to talk about is Descartes' rule of signs. We haven't talked about that in class yet, but we're going to talk about it in the context of this big problem. So we're going to first describe what it does, and then we're going to look at an example in the next video and hopefully put it together. What you're going to do is you're going to plug in, you're going to take your function f of x, and you're going to look at the sign changes between each term. Okay, the number of sign changes is the number of possible positive roots. Okay, so that's step one. You're just going to take the original function and you're going to look at the sign changes between each. Then you're going to plug the negative x in, which you could just take from up here. Like you've already done that. You plug the negative x in and you're going to have a different function because it's going to have the negative plugged in. And then you're going to look at the sign changes and the number of changes is the number of possible negative roots. Okay, and what we're going to do is we're going to create a table when we do this, and it's going to look something like this. We're going to have possible positive roots, negative roots, imaginary, and our total number of roots. And then we're going to have cases. So these are going to be possibility 1, possibility 2, and possibility 3. Okay, and we'll talk about that when we go over the problem. For right now, we're just going to write down what we're going to do in each one of these. So when I go over them, it kind of might sound like I don't know what I'm doing, but as we put it in a context of a problem, it will make more sense. And then when you know it by problem and you come back and read your descriptions over here, then that should make it a little bit easier. The next thing that we're going to do is we're going to do the rational root theorem. Cut this off here. The rational root theorem tells us the numbers, if we have a rational x-intercept, that means it can be written as a fraction, or it is a nice counting number, positive or negative, an integer. So it doesn't include complex or irrational like square root numbers or pi or e. But if this polynomial has any rational x-intercepts, what you can do is you can create a pool of numbers. It will give you more than possible, and you can synthetic divide and see if any of those give you a zero remainder. So how do I get this list of numbers from my polynomial? I'm going to do P over Q, and P is our constant term, and Q is our leading coefficient. Okay, and so what you're going to do is you're going to create a bunch of numbers plus or minus. So every time you get a combination, you're going to have a plus or minus. So if I get my leading coefficient, and these are the factors, the constant term, and these are the factors of the leading coefficient. So if I create all these numbers, they're always going to be plus or minus. So if I found the numerator was 2 and the denominator is 1, then I would have a number plus or minus 2. And we'll talk about that more when we work the problem. The next thing that we're going to do is we're going to find all the zeros, and we're going to do that by synthetically dividing. So we're going to synthetic divide numbers above until we find a zero remainder. Okay, so this is going to be one of our P over Q numbers. And this is our synthetically division, and we're after a zero remainder. And our goal is to break down the higher degree polynomial to something we can factor. So it might be we're left with a 4-term polynomial that we can group and factor. It might be that we're left with a quadratic that we can try to factor, use the quadratic formula to find irrational or complex roots. Okay, once we get all of the factors of our polynomial, we'll write the polynomial. Right, so it'd be something like x, x minus a times x plus b, c times x plus b. Okay, and then we're going to look, do any of those occur more than once? We've already done this. Does it bounce or does it cross? So you're going to list those just like we did before. And our y-intercept, remember, is the constant term. We're going to talk about our end behavior. Remember, even positive is up and up. I'm just using arrows now, but you should know how to do the more formal notation. If I have an even degree with a negative coefficient, it's down and down. And if I have a odd and it's negative, let's do positive first. Then it opens like a regular cubic, which is the right end goes up, the left end goes down. And then if I'm an odd negative, the right side goes down and the left side goes up. Oh, the one way I remember those, the odd ones, is the positive. The right end always does what the sign says. So I know they oppose, so it's positive, so the right end goes up in the positive direction, and when it's negative, the right end goes down in the negative direction. And I know the other side does the opposite. Domain, we know this is here. This depends on your graph. Sometimes it's negative infinity to infinity. Sometimes it reaches a max if it's an even function. Increasing and decreasing, I would just remind yourself to, these are my x. And then at the end, we're just going to do a rough sketch. Okay. And I know that was kind of quick, and you might say, I really don't understand what Mr. Pavnich just said right now, but trust me, this will be a nice page to kind of go back and reference to. Um, so we're going to have the other example on the left side. This is glue on the right side, and hopefully you'll be able to look at the words and an example to the left of me doing it and kind of put those together when you're working on your own. Um, I'll see you in a few minutes on the second video.